Over the last few years, many parts of the Northern Hemisphere have had some rather unusually cold and snowy winters. And one of the reasons for that is something called sudden stratospheric warming. So how does it work? Well, let's start by taking a look at a cross-section through the atmosphere. The lower level, known as the troposphere, extends from around the surface to about 10 kilometres, and it's where most of our weather actually takes place. Above that, we have the stratosphere. Here the air is much thinner, much drier, and there's actually little or no cloud. It's also where we find the ozone layer. Now, during the polar night, the air across the pole or over the top of the pole becomes very, very cold. There's no sunlight to warm it up. And in fact, temperatures in the stratosphere can fall as low as -70 or -80 degrees. Now, around the edge of that cold air, we get a ring of strong westerly winds forming. That's known as the polar night jet. Occasionally, you'll find a disturbance coming up from the troposphere to affect that polar night jet. It makes it wave more, it makes it wobble, and when those wobbles get big enough, they actually start to break, just like waves breaking on a beach. When that happens, the winds weaken and even reverse direction around to an easterly. And once the winds weaken, that allows the cold stratospheric air to collapse downwards in towards the pole. And as it collapses downwards, it compresses and warms rapidly, and that's what we see as sudden stratospheric warming. This graph shows just how dramatic that warming can be. The green line is the average temperature in the stratosphere, but look at the red line. That's the actual temperature measurements, and it shoots up by 30 or 40 degrees Celsius in the space of just 2 or 3 days. But remember, all this is taking place high up in the atmosphere. Sometimes, though, those reversed winds, those easterlies, can actually work their way down into the lower atmosphere, weakening the jet stream that normally pushes weather systems from west to east. Instead, high pressure takes over. We call these blocking highs. They allowed cold surface winds to escape from the Arctic, northerlies or easterlies, bringing the threat of hard frosts and perhaps even heavy snow. So a sudden stratospheric warming can be a useful sign that a cold snap is on the way, but it's not foolproof. Only about 2 out of 3 warming events actually result in a following cold snap.